10, I am going to present our project topic recommendation system using graph neural network. In recent years, graph neural networks, which can naturally integrate node information and topological structure, have been demonstrated to be powerful in learning on graph data. These advantages of graph neural network also provide great potential to advance social recommendation, since data in social recommendation system can be represented as user social graph and user item graph. So, here in our project, our problem is to predict the rating as a part of the recommendation system. So, here we have tried to implement the basic recommendation system using the social network structure. So, this overall architecture having three main components. The left one is the user modeling and the item modeling and the rating prediction. In user modeling, the aim is to learn the user latent factor. The challenge here, how to inherently combine the user item graph and the social graph, because in user modeling you have two kind of thing. One is the item aggregation and another is the social aggregation. In item aggregation, it is utilized to learn item space user latent factor from the user item graph. And the second type of aggregation, which is social aggregation, where social space user latent factor is learned from the graph. Then finally, we concatenate these two latent factor and we get one user latent factor from the user modeling. On the other hand, in the item modeling, which is shown in the right part of this architecture, we do something called user aggregation. Here we use a similar method as learning item space user latent factor via item aggregation. So, we will come to the detail part while I will walk through on the code part. So, let me walk through on the code part. So, here I have built one Colab notebook which is having free GPU access. So, the first step is to import these required packages. As I am running in the Colab notebook, I have uploaded the data file in the drive itself. So, let us execute that shell. Then I am changing this directory to whatever folder I have saved, all the folders, everything. This is the system architecture, overall system architecture. Now, let us load the data first. So, for the dataset we have taken Epinions dataset, which is publicly available dataset, and it can be got from the Kaggle website also. It is a real world dataset which is widely used to evaluate many of the recommender system in the literature. In this dataset we have two sort of information. One is the user ratings on the items, another is the explicit trust or distrust relationship between users. So, as you can see, after loading the load mat, the rating.mat file, we are getting some rating information. So, this kind of matrix, and another is the we are getting the trust information like the friend ID. Then we are just trying to prepare two lists. One is the user item list, another is the user list also. Let me just execute some of the shell here. So, we are preparing training, validation and testing sample by some splitting 90%, 10% and 10% as the split ratio. So, we have training samples of 73,054 and the valid and test samples have the same number of inputs. Now, we are saving this data into pickle file for loading in future. Then let me show you some of the data frame how it looks like. So, in the training data frame we have three kind of label. One is the user ID, another is the item ID, another label. So, here label is the rating. So, for an example, user ID 1 given rating 3, that is the label 3 to the item ID 8. In the same way, if you see the last row, user ID 22,166 gave rating 5 to the item ID 53,125. Now, we have all the information from the rating matrix file is ready. So, we can have 27 types of rating starting from 1 to 27, that I have already shown here, the maximum level and the minimum level in these two cells. Next, I am trying to prepare one user item list. So, as you can see in the user item list, what I am doing, I am just adding the item ID and the corresponding rating for each of the user, and that is creating a list. For an example, while this cell is running, let me show you that user item list index number 3 is showing for the third user what are the corresponding item and the corresponding rating. So, for the third user, he has given rating to item number 57 to rating 15, item number 50 to rating 10, like that. In the same way, I have also prepared the item user list. So, in the item user list, for each of the item, I have saved who is the user gave the what rating for that particular item. For an example, let me show you on the second index of this item user lists. So, for the second item, user ID 9729 gave rating 2, and likewise user number 9789 gave rating 2 for that particular item, second item. So, this way I have prepared the item user list. It will take some time to just execute this cell. Okay. While it is running, I will just show you the code of to process the trust information as well. So, in case of trust information, I am creating a data frame where we have two column, user ID and the FID, which is the friend ID. So, who are the friends for the particular user ID 2? So, here you can see in the example. So, for the user ID 2, we have so many friends, like 7659 is the friends. So, from the trust matrix, information matrix, we can get those informations. Once that cell is running is over, I will just try to run this cell. While doing that, let me just show you. So, likewise, from the trust information, whatever list we need, like user item list and the users item list, we have saved in a pickle file. When we load the training loader or validation loader, those pickle files we will just reload. So, this is a one time activity. Once the pickle file is saved, we do not have to do any kind of pre-processing. So, till this part, it is kind of data pre-processing of the Epinions trust network dataset. Let me check how it is. Okay, 48%. So, here I have prepared one graph dataset class, basic graph dataset class, where the user item list and user list and the users item lists also is taken. So, after preparing the graph dataset class, there is one more function we need, that is collate function. So, in any problem like in NLP problem also, when we are just trying to process any sequence, there should be some length, maximum length that we can process. So, here also for each of the user, there might be multiple items, variable items for multiple users. So, for that reason, we have taken a truncated length of 50. For a particular user, we are taking a list of 50. If it is more than that, we are just truncating. If it is less than that, we are just padding by some zeros ratings, by some zero values. So, this function essentially, collate function essentially take a batch of the input batch, and based on the user item length, it truncates or padded. Okay, the cell is almost covered 86%. Just wait a minute. It will be done by after 25 seconds. Okay, now it is done. So as I said, you can check any of the index, you can check that. So this item user list is given for a particular item, who is the user and what rating he has gave for that particular item. Let me process the trust information quickly. That I have already told what is the trust data frame is. For each of the user you have the corresponding friend ID. Likewise, here we are preparing the users item list and the user item list, which would be required for this architecture. Then finally we are saving the trust information in a pickle file. Okay. So this is the basic graph dataset class. The next I have already talked about the collect function, which is used for padding and the truncation. Let me run this to share. Next, I am coming to the components of the architecture in order to implement. So we have already three components. One is the user model, another is the item model, and is the rating prediction model. And there are some two common module which is required for this architecture. One is the multi-layer perceptron, another is the aggregator function. So if you see this architecture, let me show you here. Yeah. So the left one is the user modeling, item modeling, and rating prediction. So for these three architectures, some common thing is the aggregation and the multi-layer perceptron. So this is to separate. So this multi-layer perceptron is basically a sequential network, which is we have two linear layer, and in between two linear layer we have one ReLU function for that. And for the aggregator function, we have simple one linear layer followed by one ReLU function. Next, in order to implement the user model component, we have two kind of thing. One is the item aggregation and is the social aggregation, right? So from the item aggregation, we will get one latent factor, and from the social aggregation, we will get one social latent factor. And lastly, we will concatenate these two to get user latent factor. So in the code itself, you can see. So we are taking user embedding, item embedding, and rating embedding. These three embedding has been initialized by some random number initially, that I will show you quickly. Then if you can see in the forward function, we are getting two kind of value. One is the HII, another is the HIS. So HIS is kind of social aggregated latent factor, and HII, which is kind of this one, the item aggregated latent factor. Then lastly, we have already concatenated these two, and we pass to the multi-layer perceptron in order to get one user latent factor from the user model module. So this whole class is responsible for giving me one latent factor by the user modeling. And in order to get the item aggregation factor or social aggregation factor, we are almost kind of doing the same thing. We are just calculating the user item attention vector also. Here also we are calculating the user item attention vector. Then basically we are just aggregating those informations. Once we are done with the user model component, the next component in our architecture is the item model component. So in the item model component, we will get only one latent factor, item latent factor. So here basically we are getting only one factor, that is the item latent factor ZJ. So it is also basically doing the same way. We are just passing first to the user embedding, rating embedding, to the multi-layer perceptron. Then we are just forwarding this to the aggregator function. So here I have used the GPU in order to train this model. Now lastly, the last part is the rating prediction, that is the basic, the recommendation module. Let me run this item module quickly. Now in the recommendation module. So in the recommendation module, we have, you can see that we are initializing the user embedding, item embedding, and the rating embedding. The user embedding is nothing but the number of users and the embedding dimension we take. That is a sort of hyperparameters. So in our case, I have taken the embedding para dimension as 64. In the same way, item embedding has been initialized with number of items, and the embedding items is cross the embedding dimension. So the rating dimension is. So we can quickly check what is the number of users, items, and these things quickly. Okay. Now, in the recommendation module, we have a two linear layer, and they are followed by the ReLU function. And in the forward function, you can check. So in the rating prediction, you can check we are getting one user latent factor from the user modeling, another from the item latent factor from the item modeling. It is clearly visible here. From the user modeling, we are getting one vector, and from the item modeling, we are getting another vector. Then we are just concatenating these two vector, and we are just passing to the multi-layer perceptron. We are getting one rating. So this rating is the output of this recommendation module. Then we have set some hyperparameters. The batch size you have taken 128, some learning rate. Then we are just loading those saved pickle file that we have saved. So this cell is actually creating the data loader for the training, valid, and test loader. Then we are just preparing the data loader. So while we are preparing, we are just sending the data by batch size, and we are just passing that collect function in order to truncate or padding depending on the length. If you want to check what is the train loader is doing, we can just have a quick look. It is the sum of the tensors. Okay. Now lastly, we are just creating this module, the recommendation module, by passing the user count, item count, and rate count. Let me show you what is the value of this thing: user count, item count, and rate count. So we have 22,166 users, we have 27 different kind of rating, and number of items that is possible 2,96,277 on this Epinion networks dataset. So on this dataset we have trained, we have used the RMS prop as the optimizer function, and as we are predicting some value, continuous value, the rating, we are just use the loss function as the mean square error loss. Then we are just passing to some optimizer. So let me train this for a single epoch. It will take some time instead to already train. So here I have already showing the result after one epoch is done. Let me show it in live. Yeah. So the training is running. Yeah. So after each of the training epoch, it will show the validation loss for each of the epoch. For the sake of time, I have already run it for 5 epochs. You can check that. See, for each of the epoch, the validation root mean square error is decreasing. So it started with 3.6678 value, and it after 5 epoch we got 3.0820 value. And we have saved those checkpoints after training, and in the test data set I have also tested it. The root mean square is coming 5.0. So this value is only after one epoch also. So if I load the checkpoint file after 5 epoch, the RMS will be very much reduced. I have also pushed our code in our in the repository. I will share those repository in the Google form. So recommendation system using GNN. So the data for the Epinions dataset is also the 2 matrix rating and trust network is available here, and the corresponding Colab notebook and the Python file with the requirements file is also uploaded here. Thank you.